For the Pracky, try to go through as quickly as I can. For the first one, the probability of C happening, there's 6 different areas and they're all equal, so it's 1 out of 6 chance since there's only one C. 1/6 is B. Then on the second one, a chance of getting a vowel. The vowels are A, E, and just A and E. So the chances of getting those are 2 out of 6, which ends up being 1/3. And that's, they're going to say about 33%. To get not D, that's 5 out of 6 chances. Picking month of the year by tossing a coin, 2 separate events, you would just be, 1 month out of the year is 1/12, and you multiply that by 1/2. It says 1/24, but it's just asking you how many opportunities or times that it would happen, be 24. Rolling a number cube and tossing a nickel, 6 chances for the number cube, and half a chance for that. So there would be 12 opportunities or 12 outcomes, and that's D. For number 6, you have 3 different options from each. It would be a regular, a delicate, or extra dirty. So it's 1/3 of a chance there. Hot, warm, and cold, 1/3 of a chance there. And then rinse or extra rinse, regular or extra, it's 1/2. So that would give us 18. 3 times 3 times 2, which is H. For the next one, what's the total number of outcomes? Choosing a number from 1 to 10 and a day of the week. So you have 1/10 and 1/7. And you'll end up with D. And number 8, if stores handing out coupons, 10%, 15, 20, 25 off, each coupon's most equally likely, which could be used to simulate the situation. Since there's 4, you just spin a spinner with 4 things. Experimental possibility is, or probability, is just what happened. So 7 heads, 7 tails, or 3 tails. So what's the experimental probability of tails? It's 3 out of 10 in this case. Is that always going to happen? No. So what's the chance? What's a theoretical? Is 1/2. 1/2. What's the best comparison between theoretical and experimental probability? Tossing heads. In this situation, which what they're asking is, the 1/2 is less than what happened. That can happen with experimental. Those types of things can happen. Number 11, if a bag contains 4 red marbles and 2 white marbles selected, since there's 6 opportunities, what's the chance that it would be red and then white? So the chance of being red, and this is one of those dependent ones, if it's a 4 out of 6 chance to be red, and then you're going to do, after you're done with that, you're going to do white, and you're not putting it back in, then you're just going to multiply that by 2 out of 5 chances, so it's 8 out of 30. And they are going to simplify that to be 4 out of 15. The next one are those permutation things. So it's the probability of 8, 3. That just means it's 8 times 7 times 6. So you have 8 things you start with, and then you're going to go down 3 of them. And when you work that out, it becomes 336. You just use a calculator for those, and that's H. On the next one, you start at 10. It's a permutation type thing. 10, then you go down 4. So 10 times 9 times 8 times 7. That will give us, you use your calculator, 5,040. It's the same as one of the answers in our problems, and that is C. On the next one, you start at 12, and you work your way down to just 3 down, and that's going to give us the answer, it's 1,320. For number 15, it's just they're independent events. It just asks you to you're going to roll a 6, and it's like 6-sided die. So you're going to roll a 2. That's just 1 out of 6 chances, and then you're going to pick a letter from the word music, and there's 5 chances of that, and to get an S is 1 out of 5. So it actually becomes 1 out of 30 chance, and that's to find out a P and then a consonant. Consonants are ones that aren't vowels. So a 6 is a 1 out of 6 chance. And a consonant is the ones that are M, S, and C. So 3 out of 5. So you get 3 out of 30, which becomes 1 out of 10. And on this page, finally, the jar there's 5 blue marbles, 6 yellow, and 4 green. So what's the probability of randomly choosing a yellow, not replacing it, and then choosing a blue? Same ones that we were practicing earlier. And the chances of getting a yellow are 6 out of 15. And then the chances of, without replacing it, chances of getting a blue one then is 5 out of 14. And if you work that out, simplifying, you're going to find out that you would get 1 out of 7. I'll do these ones a little bit quicker, but on that first one, it's just asking you if you're going to visit them, how many different orders can you have? Anytime it asks you for how many orders you have, you multiply them all together, like 5 times 4 times 3 times 2 times 1, since there's 5 of them. So 5 times 4 times 3 times 2 times 1. And if you multiply that out, you get 120. This next one's just a little bit confusing, but it really isn't that bad. So they're given a 3-digit employee identification number. They have all the digits. So you have 0 through 9, and I'm guessing that they're going to say it can only be 9 because they wouldn't have the 0 in there. So if, well, maybe they would. So if you have 3 numbers, it would really be P10, 3. And I guess the first number can be 0 on this one. So and why is it a permutation 10, 3? It's because there's 10 possible digits, and we're only using 3 of them. So it's 10 times 9 times 8. Those would be the chances. And that adds up to be 720. Number 3, that was confusing on one of the assignments. So there's 26 students in his social studies class. He will randomly select one student as spokesman and a second student as alternative spokesman. So it's just a permutation of, it's 26, because there's 26 possible choices, and then it's just, they're picking 2 of them. So it's really probability would be 1 out of 26 times 1 out of 25. And that's 650 ways. For number 4, you just work it out. The theoretical is 1/5, the experimental is 2/5. Why does it happen? It just happens. The more times you do it, the closer you're going to get to the theoretical. 5 is kind of hard. It's really not that bad. It's just how you're going to do it. You just use a calculator and do the percents. That's all. Number 6, just multiplying them to find out how many outcomes. It's 1,512. Tossing a dice and these things, you're just multiplying them together. You're going to get 96 different outcomes. And 4 friends sit at the table at a movie in 4 seats. And this one's a permutation one. It's 4 times 3 times 2 times 1, because it's really just how many different orders that you can go. That equals 24.